Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video what I want to do is I want to cover more detail on arrays. Okay, basically now we know what arrays are and working with arguments, but I want to show you some more tricks on how you can create really kind of useful scripts for yourself. Okay, because even without creating full-on applications, you can create really useful scripts that will be useful in your daily life. Okay, so let's work with arrays and kind of see some of the deals here. Okay, so let's just first work with arrays, and we'll do an array.ts because we'll mainly teach through Typescript. But again, anything I do in Typescript you can do in JavaScript. Just you don't need to worry about types. That's generally the theme of the story. So again, I can declare arrays, and again, generally when you're working with arrays, always declare them as a const. Okay, so I'm going to say const, number array, which is going to be an array of numbers, because again, we declare it as an array, and then inside the diamond, we say, hey, what kind of array it's going to be, and then we have to actually give it some values: 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's just talk about so we know how to make an array and we know how to access its values using an index from the previous video. But there's a lot of other cool things you can do with arrays. Okay, and they have and again, they're an object. Okay, so now we're getting into like everything is an object once we get past numbers, booleans, and strings. Those are the primitive values, meaning they're just sort of your raw individual values. An array is a type of object that can hold multiple values. And built inside of arrays are several like functions, okay, that exist. So if I want to kind of see all the different functions, if we want to try out the different functions, let's try them out. Okay, so first we'll try out, let's use reverse. Let's just do something simple. Reverse. Okay, so we'll console log the result. So basically what reverse does is it reverses the array, which means it'll actually mutate the array. So let's talk about this whole concept of mutation. Mutation means you're changing it. Okay, so we have this array. When I use the reverse function, it's going to do two things. It's going to change the actual array, but it'll also return itself. So I'm going to get back that reversed array as well. Okay, so if I do this, okay, and I put it inside the console log, I say, hey, number array dot, and you can see here arrays have lots of functions. Again, whenever I do that dot, VS Code is going to help me out and show me everything that's inside that object. Okay, so I have all sorts of different functions I can use for all sorts of different really cool things. And the cool thing is that it gives you a description. So you can see over here, there is a description. So if I'm wondering, hey, what does that function do? And then it gives me like a description. So saying, hey, this is a method for arrays of numbers. So if I take this array and then I use for each, and then these are the arguments. The arguments should be this. Okay. So in this case, we want to use a reverse. So if I go to reverse, let me go find it. Reverse. See, it takes no arguments. So there's no arguments, and it's just going to return reverse. It's going to reverse the elements in the array and returns a reference to the same array. So again, like I said, it's going to flip over the array, so change the original array, and then return itself. So if you're ever wondering, take advantage of your tools. Your tools are there to help you. So reverse. And again, it's a function, so you got to make sure you put the parentheses after it. Anytime it's a function, you got to put parentheses after it, or else you're not using the function. You got to invoke that. And then again, when it's a function that belongs to a type of object, we specifically call that a method. Okay, so a method, and again, a function or a method is just a thing we can call by putting the parentheses after it, and then it'll do a thing. In this case, it reverses the array, and so forth. So now if I console log this, so we're going to do Deno, because it's a Typescript file, so Deno run array.ts, and see we get the array in reverse. Cool. Okay, so that's what reverse does. So that's one of the many methods we can go over. So let's do another method. Well, actually, what I'll do is we'll go console.log, and then just choose another method from the list. Dot, and let's take a look what we got. Let's do, concat just adds two arrays together. So if I wanted to do something like this, So let's see here. Again, we'll read the description. Combines two or more arrays. This method returns a new array without modifying. So this one does not mutate the array. So technically the original number array will still be, reversed with the same numbers it has before, but it will give me a new array with all the stuff added together. So let's try that out. Concat. So what I would do is I would say, hey, I want you to add this array to it. So this array with like 3 number 5s. So it'll add these 2 arrays and then return that value. Okay, so you see here, it returns that array, but it did not change the original array. Okay. 2 arrays to make a new array. So it gave me back a new array, but did not change the original array. We can test that out. Console.log number array. So if I console.log again, you'll see here, even though again, when I console log the result of concat, it gave me back this new array with 3 5s at the end. The original number array is still intact. Okay? And that's important to kind of know which methods are going to actually mutate the original array versus which ones are going to do changes but give me back the changes in a new array without touching the original array. Because that's going to change sort of like, do I want to save, because I can save that result in a new variable. So I can take the result of this function, and if I really wanted that array for later use, I could save it in a variable. Okay? So why it's good to read sort of those method descriptions. Okay, and then we'll do, we'll just again kind of do it the same way. Console.log number array dot, let's take a look. Okay, let's like do push and pop. Okay, let's just do all the adding and subtracting. That should probably be the first one we did. Okay, so adding and subtracting values from an array. So what I'm going to do is this. I'm just get rid of this console log first. Okay, so I'm going to say number array dot push. I'm going to push the number 8. Okay. Cool. Now watch what happens if I try to make this a string though. 8. See, that's going to give me an error because again, I told it that this particular array is a number array and it's supposed to only be numbers. That would not happen in normal JavaScript. Normal JavaScript would just be, I don't care, anything can go in an array. These are the reasons why we like to use Typescript, because Typescript can catch us from making mistakes. I intended this array to always be numbers, so now if I try to do some sort of code that might add a string to it, it's going to tell me, hey, you're not supposed to do that. This is not going to do what you told me you want to do. And that's the benefit of typing. That's the reason why people like to use Typescript. Okay, you get those. It'll help you catch yourself. But if I push a number, it's like, hey, technically this is an array of numbers, so it's fine to push in a number. So this is going to add the number 8. But specifically, it adds it at the end. Okay, then if I do number array dot pop, this is going to remove the last number from the array, which actually would be the same number. So let's do that first. Number array dot pop, and that's going to remove the last number or the last item in the array. So I imagine if this is the array at that point in the code, because again earlier in the code we reverse it, it's going to end up removing 1. We're going to pop 1 off and then add 8 at the end. Okay, so let's test that out. Console.log number array. Okay, and see that's what happened. 1 got removed, 1 got popped off the array because pop removes the number at the end of the array, and then we pushed 8 on, which puts it at the end. We could also use number array dot shift, and this is going to remove the first thing in the array. And then if we do number array dot unshift, this is going to add a number in the front of the array. So we'll add 9. Add 9 to front of the array. And let's console.log the result. console.log number array, and we'll see the changes to it. Okay, and see now, again, the number 7 was shifted off, and then we unshifted 9 to the front. Okay, so you can see like these particular methods, they mutate the array. So they are changing the actual array. Okay, so pop, push, shift, unshift are mutations. They're going to mutate. Okay, let's see what other functions there are. Number array dot. Okay. Ooh, I know, we want to use splice. Now what splice does also allows you to remove things from the array, but you can remove things from anywhere. So what you do is you say, hey, where do you want to start removing? So right now, this is where the array leaves off from where we left off on line 17. Okay, so let's say I want to remove the number 5 and 4. So 5 would technically be, let's see, this would be the 0 index, then the 1 index, and then this would be the 2 index, because again, it starts 0, 1, 2, 3, 4. So I want to start removing items starting with the 2 index. So the first argument is the index that you want to start removing from. The second number is how many items you would like to remove. So I'm going to say, hey, I'm going to remove 2 items. So then I'll console.log number array so we can see the result. Okay, and again, splice removes and or at and maybe adds items anywhere in the array. We'll go over the add part in a second. But right now what I'm saying is like starting from the second index, which would be 5, remove 2 items. So it should remove 5 and 4. So let's see, is that the result? Yep, 5 and 4 are gone. Cool, what if I wanted to replace them with something? So let's say I decide I want to replace them. Anything after that second argument will be injected where we remove the items. So I'm going to replace them with, let's say, the number 99. Okay, so now if I run this, see where 5 and 4 was is now replaced with the number 99. Okay, so splice allows you to remove items. It can allow you to add items. Let's say I didn't want to remove anything. I just want to inject 99. I could just say, hey, I want to remove 0 items, starting from the second index, and just inject 99, and see it injects 99 before the 4 and the 5, because I said inject it there. So that becomes the new 2 spot. 0, 1, 2. So splice is pretty neat as far as like you can add things anywhere in the array, you can remove things from anywhere in the array, you can move multiple things. But again, splice mutates the array. So it does change the array. That's different than slice. Let's say I don't want to touch the array, but I would like to make a separate array of just the first 3 items. Okay? What I can do is then use slice, not splice. What it does, it makes a new array from a subset of the original array. So if I do console.log and I say number array dot slice, it'll ask me, hey, where do you want to start slicing from? I'll say from the beginning. Where do I want to stop? I'd like to stop with, I'd like to get the 9, the 6, and the 99. I don't want the 5. So you say what the thing you don't want is. So I want 0, I want 1, I want 2, stop with 3. So I'm going to say 3, which is 5. I don't want the 5. I just want 9 to 99. So start slicing at 0, stop at 3. Okay, and that's going to return me an array of 9, 6, and 99. Okay, but again, that did not change the original array. So if I go back and I log the original array, see, it gave me back that slice. And again, I can save this. This is an expression. Any function that returns a value is an expression, which means I can assign that value it returns to a variable. Okay? So I can be like, hey, whatever the result of this function is, this variable here equals the result of this function. So I could actually make a new variable, say equals number array.slice. Just to show you what I mean, I could sit there and say, let's just get rid of the console log and say const new array equals number array.slice. And it's going to take, this means whatever this function returns will then get assigned to this variable. And then if I console log that, new array, I'm going to get the same thing, because this array here, instead of just console logging it right away, I saved it to a variable and then logged it. I get the same thing. But now I have a variable I can use and work with that has that new array. Okay, so again, knowing what these methods and functions do, like not only what they do, but what they may give back. And again, if you're ever wondering, you can generally hover over these things and see, I can see the description. Okay, and just kind of reading this, see what's going to say here is whatever's inside the parentheses here, that's telling you what you can pass to the function. So like saying, okay, hey, these are the arguments, the starting number and the ending index. And then anything after this colon is what is going to get returned by the function. Okay, so in this case, since I'm slicing in a number array, it should give me back a number array because I'm just saying, hey, grab me these numbers from the array. And then again, here's the explanation. So VS Code is going to really can really help you figure out what you're doing. Again, I can hover over any of these methods. If I give it enough time, it'll give me a description. Okay. And again, console.log doesn't get a full description, but some will. Cool. Okay, so let's keep going, exploring different methods. Now, cool. So let's start talking about the basics of functions. Okay, so you're kind of already saw like what's called a function signature. So this is what's, so if I go back and I highlight this again, this is referred to as a function signature, meaning it just describes, I don't get to see the actual code that is sliced, like I don't see this code that's underneath the function, but this kind of describes the high level of the function, that it takes these inputs, so it takes these inputs, these arguments, and then should return me this value. Okay. To learn the next batch of array methods, we're going to want to learn a little bit about writing a function. So what I'm going to do is, for a second, I'm going to create a new TypeScript file, call it function.ts. Okay, and I'm going to show you sort of two ways to write a function. Okay, I'll show you three ways, because there's technically three ways. But bottom line is this, like the OG way of writing a function is what you would do is you would use the function keyword. Then you would give the function a name. So let's say we want to create a function that takes two numbers and gives us back a number. Okay, we'll say add 1. Okay, cool. Okay, add 1. Now what we can do is, it's TypeScript, right? So we can type it. So we can pass it a signature. We can say, hey, this is what we want this to be. Okay, so I can be like, and I am pretty sure what I can do is I can just literally just write something like this. I can put parentheses, arrow. Let me think about this for a second. No. We would just say function, then we would do the parentheses, and in the parentheses we'd say, hey, what should go inside the function? So the function should receive two things. We'll say the first thing is A, which is going to be a number, and the second thing is B, which is a number. Again, in normal JavaScript, you wouldn't do any typing. So in JavaScript, you would just be saying, hey, this takes two things, A and B. What are those two things? I don't know. Okay, so again, in JavaScript does not care what anything is. So again, anything I do here in TypeScript, you can always just do the same thing in JavaScript. You just remove the types, and it'll do the same thing, except it won't catch any kind of type errors because it doesn't think it doesn't know your intent, so it won't catch those type errors. Okay, but I'm saying, hey, you know what? This function should take two things. The first thing should be a number. The second thing should be a number. And then after the parentheses, we can do a colon and say, hey, what should this function give us back? I'm anticipating that this function is going to give us back a number. So I want a function that gives us back a number. Okay, so you see here, I have typed the function. Okay, and that's going to allow TypeScript to tell me if I'm wrong when I write it. So if I write a function that doesn't give me back a number, it's going to be like, Alex, you told me that this function returns a number, and it doesn't. Okay, and right now it's exactly doing that, saying, hey, a function whose declared type is neither void nor any must return a value. Okay, so what I'm going to do here, okay, is say, And we'll just say return. That's what the function is going to give you back when you're done. And we're going to say, hey, return A plus B. Okay, and see, now it stops complaining because it knows that A is a number and B is a number. And if A and B are both numbers, we don't know what numbers they are. But if you take two numbers and add them together, that should result in a number. And that's what we're returning. We're returning the result of this expression. Okay. So essentially a function can return a value. It doesn't have to return a value. Then the return value would be void. So if I didn't want this to return a value, I would just make this void, meaning this returns nothing. Okay. In that case, it's pretty much a glorified statement because it doesn't give you anything back. And again, a statement is just code that does a thing but doesn't give anything back. Okay, and now I can use the function. So I can be like add 1, then it says see, and see, like it just tells me exactly what I need to give it. I need to give it two numbers. So I'm going to give it 5 and 5, 6. Now right now that's not going to do anything for me. So what I want to do is take that return value and save it somewhere. So I'll declare a variable. We'll call it result, which should be a number. And see, it doesn't complain because it knows that add 1 returns a number. So since result is supposed to be a number, it knows that this function gives me back a number, so this will end up being a number. So again, as your code gets more and more complicated, having all these types are going to help you make sure that every step makes sense. Like you're like, okay, hey, I expect this function to do this. So if I expect this variable to be that, and this function gives me that, this is all going to line up. And Typescript's going to be like, okay, everything's A-okay. Again, in JavaScript, none of these checks happen. So in that case, if something doesn't work the way you expect it, you then have to go back and debug it manually, which, you write enough JavaScript, you get okay at doing that. You figure out how to do that, and you develop a sense for what the problem may be. But there's the occasion where, especially in really large code bases, where it's such a weird error that it takes forever to diagnose it. Well, with Typescript, you can diagnose it much quicker. That's the reason to use Typescript. Putting that extra discipline in your code is just going to help you prevent a lot of mistakes as your code base gets bigger and bigger and bigger, and reduce the amount of time it's going to take you to find those mistakes. Because your editor and the compiler knows what you're trying to do, because you're telling it, I'm writing a function that takes in two numbers and should give me back a number. So if the function definition, the code here in the curly brackets, doesn't do that, it's going to tell me, Alex, something's wrong. Like, for example, if I try to return the word cheese, see, it says, hey, no, that string is not a number. You told me you're going to give me back a number. This function doesn't do that. Okay, so it'll help us catch problems. Okay. Cool. So theoretically, when I run this code, this function should run. When I run this function, it's going to rely on this definition. So it's going to be like, okay, hey, you ran this function, you invoke this function. So I'm going to do the instructions that you gave me, which are right here, which is just take A, which is the first number, and B, which is the second number, and return A plus B. And then we're going to save that, which should be 11. So just to double check, did that do what we think it's going to do? Console.log result. Okay, now if I run this, actually I want to run function. So let's run function.ts, then I'll run function.ts. Okay, and I get back 11. Okay, nice. That's exactly how I expected that function to work. Now there's other ways to write a function. Okay, so let's say another way you could do it, and actually probably the next two are probably the better ways to write your functions. Okay, so if I do const subtract 1, but I see, notice I'm not using the word function right away. I'm declaring it as a variable. Okay, and there's some under the hood benefits to it. We won't get too under the hood right now with the idea of hoisting, although it's something you should definitely eventually understand. Subtract 1, and then what I'm going to do is I'm going to want to type that variable. So I'm going to say, hey, this variable should be a function. Then if I'm right, the diamond should include what that function should return. I want this function to return a number. Okay, so this is expecting a function that returns a number. Okay, so then I'm going to do equals. I'm going to write a function. I'm going to use the function keyword again. I don't have to give it a name because I already gave it a name over here. So I can just write function, then do the parentheses, and again do like a number. I still want to take two numbers, b number, and then I want it to return a number. Okay. and then I can define the function. So it's the same syntax. The only difference is that I've shifted the name to a variable, which again is going to have some differences in what happens under the hood that are going to be good, okay, or generally better. Okay, but at the end of the day, I end up in the same place, and I can say, hey, I want to return a minus b. I want to subtract the two numbers. Okay, type function is not generic, should be just function. Expected equals function. Oh, did I forget a comma somewhere? Function, not generic. So maybe I just do this. There we go. Yeah, we're just saying, hey, I want it to be a function. Okay. Cool. So essentially what that's doing is going to say, hey, I want a function. This is a function. This function matches its own typing because a and b are numbers, and a minus b would result in a number. So right now, right, everything matches up. Okay. And again, I could choose to be lazy and make this any, but just so you can see, I can type things as a function saying, hey, this variable is supposed to have a function inside of it. Okay. And then I can be like const, or I mean, now I can just say, hey, const result 2. Okay. And say equals the result of subtract 1, because now that function's inside the subtract 1 variable. And just like before, use the parentheses to invoke the function and say, hey, the first argument a is 5 and the second thing is 5, because again, it expects two numbers, because based on our function definition, we expect two numbers as the input, which should give us back a number, which is what this code does, gives us back a number based on those things, and that should give us back 10, or actually 5 minus 5 should be 0. So let me console log the result, and again, I can take the return value of the function and assign it to a variable. So anytime a function returns a value, I can then take that result and save it in a variable. So functions can be expressions if they return a value. Okay, if they don't return a value, which would be type void as the return value, meaning nothing, then you're just going to get undefined if you assign it to a variable. Console.log, okay, result 2. Okay, as you can see here, 5 minus 5 is 0. Okay, so that function, again, took in a number, took in another number, and gave me back a number. Works. Okay, and I'll show you one more way to write a function. Same idea, we start with a variable, so const, we'll say multiply. I don't know why I write 1. I wrote add 1, subtract 1. I don't think we needed that, but oh well. We'll just keep with it, multiply 1. Okay, and we're going to say type it. Again, we want to say, hey, it's a function. And another way to write a function, which is like my favorite syntax for writing function, this is generally how I write all my functions because it's just less typing. Instead of having to type this whole function keyword, I can just write parentheses, arrow, curly brackets. It's essentially the same idea, okay? Essentially, this curly brackets is the same as these curly brackets, and this parentheses is the same as this set of parentheses. I just don't have to write the function keyword. The arrow sort of takes the role of the function keyword, okay? There are some differences under the hood, but we won't get into that now. Okay, and again, I can do the same thing. I can just say, hey, A is supposed to be a number. Okay, B is supposed to be a number. Okay, A and B are a number. And it should return something. It should return a number because we're going to multiply. So again, there's my signature describing, hey, this is what should be happening inside this function. When we use this function, it should be receiving two numbers. And when the function is done, it should give me back a number. So I got to return a number somehow. So in my curly brackets, I got to write code that ends in a number. I can do as much code as I want, but it's got to end in a number because that's how I typed it. Again, in JavaScript, there's no typing. So it's just like, do whatever you want. So literally, if you took out all the typing, that's how it would look like in JavaScript. Again, always, how does something look like in JavaScript? Take out the types, and then that's how it looks like in JavaScript. Okay, that's pretty much the deal. Okay, so I want to return something that gives me back a number. I could just literally return the number 5, and that would satisfy it. Like, I could pass it two numbers, and it'll just arbitrarily return me the number 5. That satisfies, but that's not really what I wanted to do with this. I want to return, A times B. Cool. And then there's my function. Okay, and see, I didn't have to write the word function twice. Okay, so but I still got my typing, and everything's very clear that this variable holds a function. This function takes in 2 numbers and returns a number. Okay, very, very nice and clear. And then again, the nice thing about this is that now if I go const result3, okay, which should be a number. Again, I should type it. Again, I should always type my variables. It's a good habit. Okay, again, in JavaScript there is no typing, but in Typescript there is, and really to get the full benefit of Typescript, you should write types on everything. Okay, it's a good discipline. Equals, okay, multiply 1. We'll give it 2 numbers, 5 and 5. Okay, and if I hover over multiply 1, okay, it's going to say const multiply 1 is a function. Okay, now again, if I go here to the parentheses, okay, let me just add the parentheses, and I hit parentheses, and I go 5. Okay. Not giving me any further type hints. Okay. Cool. But it'll tell me, okay, hey, multiply 1 is a function that returns 5 and 5. And there we go. Cool. And then if I run the code, and I didn't console log result 3, console.log result 3, 25. Okay. And then I think you could also type it with an arrow function. Let me just try this out. Let's see if this works the way I think it would work. So I could actually do this, like number. Let me do that. Oh, I gotta do arrow number. Nope, I guess I can't do it that way. I thought I could. Okay, cool. But I'm typing as a function. Okay, cool. So that is sort of what a function is. I think we've gone a little over time. But now that you know what a function is, we'll be able to do some of these extra array methods which require you to write your own functions to give to the method. Okay, to say, hey, I want to do this thing. So I'll see you guys in the next video. Have a great day and enjoy.